Hello all, this is Fahim. So, as part of my studies this week, I had to learn about a new data structure which is called tries. And it's not trees, but it's tries. And I just want to share what all I learned about this data structure in this video. So, what is a trie? A trie is a tree-like data structure in which storage of strings is very efficient, and this has a very cool real world applications that we see every day, especially if you are interested in programming. Then all of the auto completion and everything that you see on your editor might be using some kind of try under the hood, because tries are used for things like auto completion and spell checkers, because they allow for very efficient storage of strings, and also checking if a string starts with a given input. So when you have something like CA, then it can check in your dictionary very fast for all of the words that start with CA. So that is what tries are. And if I give you a pictorial representation of what a try, this is what a try would look like. We have the head, and don't mind the pretty bad drawing, but this is the head. And let's say I want to input the word cat. Then what I would store is, I would check if there is a link from head to the character C, and if there isn't, I will create this character C, and I will create from this, the next letter is A, and then the next letter is T, and so on. So that is a complete word, right? So when I reach the last letter of the word, I will have a small indicator that this word is complete, and I'll put a star there. That's what that star is. And when I want to insert some, I will insert SOME, right? Now the interesting thing is, when we want to insert somebody, we don't actually create another pointer. No, we don't do that. What we do instead is, we already have S from head, right? So we go to S, O, M and E, and since we don't have a B after E, we create this is what we create. We don't create from here itself, we create from the end of this. So essentially we are reusing a lot of the data that we already have, and this is very efficient in case of the memory usage. And we'll create the rest of the word like this, and we'll put an indicator that here the word ends, right? That's somebody. Now let's do a live of how we would insert catch. So if I was inserting catch, then I would check from the head if I have a C. I do have a C here, so I go to C. Then from C I check the next letter, which is A. I do have an A, so I go here. Then I have a T, and I do have a T from A. Next is C, right? I do not have a C from T. So what I would do is, I would create a new pointer, and this would be a C here. And since the next letter is H, I'll create another pointer from this C, which is H. And I will also have an indicator, just a pretty messy star, but that will indicate that this is the end of a word. So this is how basically the idea of how a try works. And if there are a few methods on the try data structure, like inserting. Obviously you want to insert new data, and then there's searching for a word, like to check if that word is a valid and in our storage. And then there's also the most important one, which is starts with. This checks if words start with this given input. So let's see a code representation. I will do a live coding here. So this is my try class. So before I create a try class, I would need a node. So a try node, and this node will have two things. The first thing is the children of this node. So this dot children equals just an array, and this dot complete. So what this says is, if this is true, that means a word ends here, and that is a valid word. So by default we will set this to false, and if the word is complete we'll change this to true. And this might be a bit you'll understand how we use this children array. So essentially let's now implement this try class. So here we will have this dot root equals new try node. So that's all for the constructor of the root, and that's the only thing that this try class will have. So when we are inserting a new word, what we do is we go first we have to check if the root has the first letter, right? So we will have a pointer to the current node. So the current node will initially be this dot root, right? And then we want to insert each character into the try. So we will loop through each of the characters in the word. And here I think you can still see. Yeah, so what we do is we will check if the current node has this given character, and since we are dealing with arrays here, we have to convert the character into an index, right? So what we can do is I will assume that the word will always be in lowercase. So to get an we will have to do some kind of index translation. So what we do is we will say the code will be word dot char code at I, and this will give us the character code of that letter. So since we are assuming that the input will be like a lowercase, that means the character A should be at the index 0 and B should be at index 1 and so forth, right? So what we do is we will just subtract this by this of 0. So this will give us the index of each letter. So when A comes, like if the first element is A, so that is I of 0, word of 0 is A, then this will become, the code will become 0, I mean in the index will become 0, and we can insert that there. So first we check if this is present in the current node or not. So we check if cur of index, I mean of index, we will just do it. If we do not have a children there, that means it does not point to that, we will just create a new one. And if we already have that letter, we just go to that without creating anything new. So now this will run for each character, and we will be able to insert this into the try. Okay, so this is basically it for insertion, if I'm not missing anything. So let's try doing this. And tr.insert cat. I'll just print out the root to check if I have. So here we can see there is a node at the third index, right? That means A is 1, B is 2, I mean A is 0, B is 2, B is 1, and C will be 2. And this is the second index, and we have a try node here. So that means since this is C, we have that node properly, and that is the correct application. So as you can see, we are not actually storing the character, we are storing the index, and from that index we can infer what the character is. So now if we search for the word, we should, it's like almost the same logic but a bit different. So we'll still have this current pointer, and Now what we do is we do the same thing here, and we will say it'll be the almost the same thing. I'll just copy this. There's not a big difference, but what we do here is if we do not have that children, so that means we do not have that word in the try, so we just return false here. And also when we come to the end, so when we come to the end, we will have a node with us, right? The current will be a node, and we have to check if that is a complete word, because there might be words that are not complete and current will be pointing to that. So we only want to return true if that is complete. So that is why we have this complete here. And also I completely forgot, I have to set the equals true here, complete equals true, since at the end we'll be pointing to the last node of the character of the word, right? So we have to put true here, otherwise this will return false. So here we return current dot complete. So that's basically it for the search. And if we try that here, we see true here, see. And if we do CA, that will be false, because that false is coming from here. CA is a valid node, but A, the character, does not end a word, so there isn't this dot complete will be false, so that's why we are getting a false here. So but when we do cat, that is a valid one, since we have put true here, that will be valid and it will return a true here. And let's now go to startsWith function. Now startsWith function is very similar to the search function, and this is the most important method of a try, because this is where the auto completion and spell checkers actually work. So here also we have the same logic, okay, but at the end we do not really have to check if the word is complete, because we're just checking if a word starts with. So we can if at the end we have a current, because if we do not have a current, we are returning false, right? So here we can just return true, and that will be correct. So if I console.log the startsWith of C, we get it true, because we do have a word that starts with C, right? And if we do something like A, that will return a false, because we do not have any word. So if I do insert something, then that will be a true. And yeah, that's basically it for the main insert, search and startsWith methods of the try. And as you can see, it's not that complicated. The only thing that might be a bit hard to understand is how we are storing the indexes and how we are inferring which character it is. And there is some logic here where we subtract the character code from the character code of the word's character. But other than that, it's a pretty simple data structure, and that's basically it. I hope you learned something. Thank you.